Today, we are digging into something that is fundamentally changing how we should be thinking about AI. We've all gotten used to this idea that more power is always better, right? Well, it's time to talk about a smarter, way more strategic approach.
So let's just jump right in with a question. How is it possible that the exact same AI task could cost 50 cents in one system, but only 2 cents in another? I mean, that's a 25 times difference. The answer to that question, well, it pulls back the curtain on a massive hidden problem in the way most AI works today.
And to get to that answer, we've got to first look at the old way of doing things, the brute force approach to AI. Because it has this big, expensive flaw that we're really just now starting to get our heads around.
You know, for over a decade, the core idea in AI was super simple. If you want better results, you just need more compute. That's it. Bigger models, more data, more processing power. That was seen as the silver bullet for literally every single problem. But what if the real problem isn't the amount of power you have, but how you use it? Because this whole brute force strategy, it's kind of pushed us to a breaking point. It turns out that just throwing your smartest, most powerful model at every little thing, well, that's creating a massive structural inefficiency.
Okay, so let's actually put a name to this thing. Because this concept is the absolute key to understanding that wild cost difference we saw a minute ago.
The term for it is cognitive misallocation. And all it really means is that the thinking power you're using doesn't match how complex the task actually is. It's like using a sledgehammer to crack a nut, or on the flip side, trying to demolish a building with a tiny little hammer. You're either thinking way too hard or not nearly hard enough.
And this table here just lays it out so clearly. You wouldn't use your top-of-the-line, most expensive AI model to just summarize a simple email, right? That's just crazy overkill. That's over-reasoning. But then you have the other side of the coin, using a cheap, fast model to analyze a complex legal contract. Well, that's under-reasoning, and that is just asking for trouble.
And look, the really crucial thing to get here is that both of these mistakes are bad. This isn't some minor optimization. It's a fundamental flaw. Whether you think too much or too little, you are just burning money, time, and energy. And maybe worst of all, you're dramatically increasing the risk of getting a flat-out wrong answer.
All right, so that's the problem. Let's talk about the solution, a much, much smarter way of building these systems.
And this new philosophy is called Cognitive Allocation Efficiency. It's all about intelligently matching your computational resources to the job. So you stop using a sledgehammer for everything, and instead, you start thinking proportionally. You're trying to find that perfect balance, matching the right amount of AI brainpower to how hard the task actually is. Okay, but how does a system actually learn to do that? I mean, how does it know how much effort to put in? Well, the secret sauce is to profile every single task before you even start working on it. You use a few key signals to figure out what it's really going to take. And there are really 3 big signals it's looking for. First is something called entropy. That's just a fancy way of saying how uncertain or vague is this request. Then there's novelty distance. Basically, have I seen this kind of thing a million times or is it totally new? And last, but maybe most important, is risk. What are the actual consequences if the AI messes this up? And here you can see how the whole architecture works. It's actually pretty elegant. A task comes in, the system profiles it using those 3 signals, entropy, novelty, and risk. Then, a smart router sends it to the perfect right-sized model. Not too powerful, not too weak. The model does its job, and then the output gets checked for quality. It's basically a super smart traffic controller for AI work.
So what's the actual payoff here? I mean, what does this new, efficient approach really get you in the real world? Well, the results? They're pretty staggering.
Just look at this chart. The visual here tells the whole story. That bar on the left, that's the crazy high cost of the old brute force method. And the one on the right, that's the cost with this new adaptive allocation. I mean, it is a night and day difference. And we can put a real number on it. We're talking about cost reductions of up to 80%. And get this is the really important part. That's with 0 loss in the quality of the results. This just fundamentally changes the economics of running AI at scale. It's a game changer.
But hey, the payoff isn't just about the money, which is already huge. It's actually a triple win. You get massive cost savings, sure, but you also get faster results, less waiting around. And you're using way less energy, which, is a massive deal for sustainability. And that's really why all this matters so much. It's not just about cheaper operations.
It means a better, faster experience for the user, and it also makes AI a more responsible and accessible technology for everyone by shrinking its carbon footprint.
So, let's wrap this up by looking to the future. Because this shift in thinking, it completely redefines what we even mean when we say an AI system is powerful.
Yeah, we're moving away from this old idea of computation being this infinite thing you just plug into the wall. The next generation of AI is going to treat cognition, the AI's ability to think, as a scarce, valuable resource, something you have to manage carefully.
And this is going to lead to some seriously sophisticated systems. We're talking about AI that can price its own thinking in real time, that can scale its reasoning depth up or down on the fly, and can even use other models to optimize how it spends its own thinking budget. It's pretty wild.
So, the big takeaway is this. Going forward, the maturity of an AI system won't be judged by how much compute it can burn through. It's going to be judged by how precisely it can allocate it. Competitive advantage is no longer about brute strength, it's about intelligence and efficiency. And that really leaves us with this final, powerful idea. Efficient intelligence isn't about thinking more. It's about thinking proportionally. It's about thinking strategically. And, really, it's about only thinking as hard as the task actually justifies. The smartest AI isn't the one that thinks the hardest. It's the one that knows when to.